Hey, in this video I'm going to show you how to make an RPG inventory system sort of loosely based on games like Minecraft or Valheim. I'll show you how to pick items up and how to drop them. You can also split things by right-clicking and dropping one quantity of something if an item is stackable. There's an equipment slot that can only store an equipment item and can't store something like these apples or this book. You can right-click to use items. Or if your inventory is closed, you can use some hotkeys to use things on your hotbar. You can also interact with external inventories like this chest here to put things between the two of them. And this is all resource-based, so you can see an example right here. I've got the health potions here. This is all custom resources. So there's a lot to cover here. Hopefully you get something out of it. Okay, let's just make a simple environment and player scene before we start working on the inventory stuff. So I'll click Other Node here. Just make a normal node here. I'll call it Main, Control A, add a mesh instance 3D, I'll call it ground, go over here to the mesh property, give it a new plane mesh, and then in there I'll make it 20 by 20, click this mesh menu up here, create tri-mesh static body, and then these three dots up here, I'll add sun to scene and add environment to scene, then I'll save this as main.tscn. Now let's make a player scene, so I'll click that plus button, other node, character body 3D, let's call it player, Control A, let's add a mesh instance 3D, and then let's also add a collision shape 3D for the mesh instance 3D. Let's give it a new capsule mesh, and collision shape 3D, let's give it a capsule shape 3D. So I'll shift click both of those, hold control, drag them up one unit just so that the origin is on the ground, just like that, and then Control A, add a camera 3D as well, and I'll drag it up till it's right about there. Okay, and I'll save this as player.tscn, then I'll go back to that root node, add a script. Okay, and then I'm actually going to press Control A, delete all of that, and I'm going to go to this paste bin here. I'll have a link to this in the description. I don't want to go over making the simple character controller in this video. I do that in some of my other videos, so I'm just going to click Raw, Control A, copy this, paste it here, and this is going to work out of the box, except I have to assign these actions. So I'll do that in project settings, input map, forward, back, left, right, and then forward will be W, back will be S, left will be A, and then right will be D. Okay, so save that, go back to the main scene, click the root node, Control Shift A, add player.tscn, then I'll click play and select current. And we've got a simple FPS controller. We can move around with WASD, look around with the mouse, jump, and when we hit escape, it closes out, which is easier for testing. Okay, so let's get started with the data structure of our inventory and items. So I'm going to make something like this for the data, and that is we'll make an item data resource that will store the info about the items, a slot data resource that stores a reference to the item data as well as the quantity in any given slot, and an inventory data that will essentially just store an array of slot datas. Okay, so let's start with the item data. So I'll make a new folder down here, and I'll call it item, and then in there, new script, and I'll call this script item data, and I'll have it inherit from resource. So let's create that, and then let's open that up. Here I'll give it a class name, item data, and then we'll export a few variables here. So add export var name string, and then we'll just initialize this as empty, and export multi-line var description. That'll be another empty string. Then at export var stackable bool, and we'll initialize that as false. And then last but not least, at export var texture. Now this, you can use a normal texture here if you have individual images for your items. I'm going to be using an atlas texture. So I'm going to use atlas texture here, so I'm just going to have one image that references all of my item images, and I'll show you the one that I'm using later, and you can use that one and follow along here. But if you just use a normal texture, it will also be very easy to use. So that is going to be our item data resource to start with. All right, so next let's make our slot data resource, which again is going to be a resource that references an item data and then also tells us the quantity of that item in any inventory slot. So very similarly, let's go over here, new folder, let's call this one inventory, and then in there, new script, and we'll call this one slot data. This one will also inherit from resource. Let's create that, and then we'll open it up. Give this one a class name of slot data, And we want there to be a max stack size for the inventory. So I'm just going to make that uniform across all items. So const max stack size. That's going to be an int, and I'll have it equal to 99. And then here, let's get those references that we talked about. So export var item data here, and then export range 1 to max stack size var quantity int, and we'll have that initialize as 1. And this is all we need for the slot data. All right, and last but not least, we just need to make our inventory data resource, which again is going to just store an array of slot datas here, and we'll just represent the entire inventory. So let's go back to the inventory folder over here, and then new script, call it inventory data. This will also inherit from resource. Okay, let's create that and open it up, and let's give it a class name of inventory data, and then we're just going to store one thing here at export var slot datas, and this will be an array of type slot data. And with that, we've already got the data structure set up for our simple inventory, so we can make an example of what one might look like. All right, so now we can actually make an inventory resource just to see what this actually looks like. And I'm going to be using Shikashi's Fantasy Icons pack, which is a texture atlas of pixel art items for my item textures. So I'll have a link to this in the description if you want to follow along and use this. So in the items folder here, I've got the directory open right here. I'm going to drag over #1 transparent icons. So I'll bring that over, and then we need to make an atlas texture resource here. So I'll right click, new resource, atlas texture, and we'll call this one item atlas.tres. Okay, so let's open that up. Let's drag in the texture here, and then edit region, snap mode, grid snap, set the step to 32 by 32, and then let's just set it to the skull and crossbones up here by default. So I'll close that, save that, and now let's, in the item folder, new folder, let's make another folder called items, and then let's make just some items in here. So new resource, and we'll make a new item data, and I'll call this one apple.tres. So we've got this right here. So name, I'll call it apple, description, a tasty apple. Stackable, sure, it's stackable. And then for the texture, I'm going to drag in the item atlas, and then I'm also going to say make it unique. So every time I drag this in, I'm going to make it unique. And then I'll access this here, edit region, and then I'll go down here and select the apple, close that, and then let's make one more. So in items, again, new resource, I can make another item data, and this one I'll call blue book, and here I'll call it blue book, good reading. This one's not going to be stackable, and then again, item atlas, let's drag it over here and let's make it unique. Edit region, and let's select, let's select that blue book right there. Okay, save that, and then let's make an actual test inventory. So I'll just put this in the root directory for right now. New resource, this is going to be a new inventory data. I'll call it test inv. So right here, I can see that it is an array of slot datas already. So let's give it a size of 10, and then so these will represent empty slots, but let's say in slot 2, let's make a new slot data, and we can drag in, let's say we want some apples here, and I want 10 apples there, okay? And then how about in slot 6, we want a blue book, so I'll just drag in the blue book item data there, and then this is just a representation of that, but now we need to make an actual visualization of it. Okay, so we've got our data representation of the inventory, but we don't have a visual representation yet. And what we're going to do is we are going to make an inventory scene that corresponds to every inventory data. And then we'll also put slot scenes inside that inventory scene that corresponds with every slot data. So let's start by making the slot scene. So I'll click this plus button up here, other node, I'll make the root node a panel container, and I'll call it slot, and then Control A, I'll put a margin container in there, and then in there I'll put a text direct so we can put our item texture there. Then back on the root node I will add a label, and I'll call this quantity label. And then I'll go to the 2D view here for the slot. Let's give it a custom minimum size here in the layout for 64 by 64 pixels. And I'm going to go to the text direct right here and drag in icon.svg, and you can see that it expands. So here we want to change the expand mode to ignore size, and we'll keep the aspect centered. And then let's give it some margin here. So I'll go to the margin container, theme overrides, constants, and then I'll just put 4 in all of these just so we can see the background of the slot a little bit in there. And then in the quantity label, let's put x99 in there, and let's position this. So I'll click that in the scene tree, and then up here I'll bring it to the top here with shrink begin, and then I'll bring it to the right, just like that. And in the theme overrides here, let's go to colors, font outline color, let's check that, and then constants, outline size, let's just bring that up to like 3. All right, and then I'll save this in inventory, slot.tscn, and this is a good start to our slot scene. All right, so we have our slot UI scene set up, but we still need to make an inventory UI scene that can hold those slots. So let's hit this plus button again. I'll make this one also a panel container, and I'll call it inventory, Control A, add a margin container, Control A, add a grid container, and I'll call the grid container item grid. And then let's Control Shift A, add a slot to it, and then Control D just to duplicate some. Let's put 6. And I'm actually going to make each row hold 6. So I'll click Item Grid, and I'll set columns to 6. And then I'll Shift click all these, Control D 2 more times. So this is what the inventory would maybe look like right now if we had 18 items in it. I'll go to margin container, theme overrides, constants. I'm just going to put 8 margin on all the sides here. And I'm pretty happy with how that looks, but I don't actually want these slots to be added in here by default. We're going to add them programmatically, so I'm going to just shift click all these and delete them. Then I'll save the scene in inventory, inventory.tscn, save that, okay, and we're done. All right, so let's actually get this inventory on screen. And before I do that, I just want to clear up one thing. So this structure that I've got going right here, it kind of looks like the inventory data is going to be stored as a part of the inventory, and that's actually not going to be the case. I probably could do better with this visualization, but I'm kind of just winging it. So in actuality, what's going to happen is there's going to be an inventory interface node in the main scene that's going to be able to store multiple inventories, like a player inventory and an external inventory, like a chest or something. And this data is going to just kind of live in parallel, and we'll wire it up, and these will communicate together with signals, all right? None of these nodes are going to store references of the data, all right? They're all going to communicate with signals, and that's just how I'm going to structure it. So let's go to the main scene and set up that inventory interface. So Control A, I'll add a canvas layer, and I'll call it UI. And then Control A, I'll add a control node, call it inventory interface, and then I'll go up to the anchors here and I'll make it full rect, and then Control Shift A, add an inventory and call it player inventory, and then I'll go to layout, transform, and I'll just add 10 to the position of X and Y just so we've got a little bit of space there on the sides. Let's hit play. And we can see it up in the top left, it's empty, and we can't move with the mouse, but that's totally fine. We're going to fix that later. Our first order business is to actually populate this with our test inventory. All right, so we want to fill our inventory UI scene with slot UI scenes. Let's start working with that idea. I'm going to go back to the inventory scene, add a script to the root node, inventory.gd, and if we're going to fill this with slot scenes, we're going to need a reference to a slot scene. So const slot equals, and then I'll go to the inventory folder, drag in slot.tscn, hold control as I drop it to preload it there. And we're actually going to be putting these as children of the item grid. So I'll drag an item grid, hold control to get an onReady reference to that. And let's make a function to fill this with slots. So func populate item grid, and we're going to pass in an array of slot datas here to make a slot for every single one. So slot datas, that'll be an array of slot data, and this can just return void. And the first thing that we're going to do is we are going to clear the item grid of any children that it currently has, because we'll be using this function as the inventory updates in the future as well. So for child in item grid.get children, child.queueFree, and then let's go ahead and make a slot for every slot data in the array, and then we'll add it as a child to the item grid. So for slot data in slot datas, var slot equals slot dot instantiate and item grid dot add child slot. Okay, so how can we test this? For the time being, we're just going to make a ready function here, And we're just going to say var inv data equals, and then we'll just drag and test inv, hold control to preload it. And we'll say populate item grid inv data dot slot datas. So let's see what that looks like. Okay, and we actually don't have a very large inventory, so I'm going to go back to test inv here, and I'll just increase the size to 18, because I think that's what we're going to use for our player inventory. All right, and there we go. So we've got a slot for every slot data. Now we just need to focus on actually displaying the correct slot data. All right, so let's make it so that these slots actually display the slot data that we're passing in. So the first thing that I'm going to do is I'm going to go back to my slot scene 2D view, and I'm going to update these so that it will reflect an empty slot. So in the texture rect, I'm just going to remove this base texture. We don't need it anymore. And for the quantity label, I'm going to hide this by default. So I'll save that, and then I'll go back to my inventory script. And what we're going to do is in this for loop in populate item grid, we're going to check to see if there is a slot data. So if the slot data is null, we don't want to do anything. We just want it to be empty. And if there is slot data, then we'll pass in that slot data to the slot to update some parameters. So here we'll say if slot data, so it will only enter this if statement if slot data is not equal to null. This is saying the same thing as is not equal to null. So if slot data, then we'll say slot.set slot data. All right, so now we need to make a script and create this function. So I'll go back to the slot scene, create a script, slot.gd, and let's say func set slot data of type slot data, and this will return void. And we're going to need a reference to the texture rect and the quantity label. So I'll control click those, then drag them in, hold control, drag them in and hold control as I drop them. And let's get a reference to the item data here. Item data equals slot data dot item data. Let's update the texture. So texture rect dot texture equals item data dot texture. We're also going to set the tooltip text here. So tooltip text equals, this is going to be a formatted string. Let's make it so that it's the name and then it's a new line, and then this will be the description. So we'll pass in item data dot name and then item data dot description. And then last we'll take care of the quantity. So if slot data dot quantity is greater than 1, then we'll say quantity label dot text is equal to format string. We'll put that X there and then %s, and then we'll pass in slot data dot quantity. And if it's greater than 1, then we want to show the quantity. So quantity label show. So let's see what this looks like. All right, that's looking pretty good. So I just want to address one small bug really quick, and that is if I go into the test inventory here and I go to our blue book and I set the quantity to 2, remember blue book is not stackable. It still will show that it has a quantity of 2, so we want to set up a quick safeguard for that. And so we can do that in the slot data script. So I'll go Shift, Alt O, search for slot data, just open it there, and then let's make a setter function here. So :set equals set quantity. Then let's make a function. So func set quantity value, that'll be an int, return void, and so it'll be quantity equals value. And then here we'll do a check to see if the quantity is greater than 1 and it's not stackable, we'll throw an error and we'll set the quantity back to 1. So if quantity is greater than 1 and not item data stackable, then we'll set the quantity equal to 1 and we'll push error and we'll just say is not stackable, setting quantity to 1, and then we could just pass in item data dot name just so whoever is creating the item data gets an idea of what the problem is. So let's take a look at that. Okay, so we can see that the blue book is set to a quantity of 1, and if I go to the debugger down here, it is pushing an error here. So let's go back to the inventory and we can just fix that, and now we have nothing to worry about. All right, so currently we're passing in this inventory data by hand in the ready function, and let's go ahead and delete this, because in reality what we're going to do is we're going to store the data in the player scene, and then we'll use the main script to pass that data into the interface and pass that into the inventory. So let's go to our player script, and then up here at export var inventory data of type inventory data. Let's go to the main scene here, click player, and let's drag in our test inv there. And then let's make a main.gd script, and let's get a reference to our player and inventory interface right here. So in the ready function, we'll say inventory interface. We'll make a function called set player inventory data, and then we'll pass in the player.inventory data. Okay, so let's copy this function name and let's make this inventory interface script. And I'm going to put this in the inventory folder, and I want to follow the same naming convention, so inventory underscore interface, and let's create that. So the function can go right here, func set player inventory data. That'll be inventory data, type inventory data void, and let's get a reference to the player inventory. So control drop that, and we'll just do the same thing, player inventory dot set inventory data, and I'm just going to copy this entire signature right here, and we'll go into the inventory script. So right here, paste that in, and let's get rid of player here because it's just set inventory data for this one. And here we'll just call populate item grid, and we'll pass in inventory data dot slot datas, and this should work. There we go. Let's make it so that we can toggle between having the inventory visible and not. And when it is visible, let's make sure that we can actually see the mouse so we can interact with the slots. So I'll start by hiding the inventory interface by default, and then I'll go into the player script, and here I'll add a signal toggle inventory, and then I'm actually going to go to project settings, and go to the input map, and I'll add an inventory action, and I'll assign this to tab. Okay. Then down here in unhandled input, if input is action just pressed, I'll use inventory, and then I'll say toggle inventory dot emit, and then in the main script right here, I'll do player dot toggle inventory dot connect, and I'll make a function here called toggle inventory interface. So I'll copy this, and func, paste that, void, then I'll say inventory interface dot visible equals not inventory interface visible. So this will flip every single time we press tab. And then if it is visible, let's make it so that we can see the mouse. So if inventory interface dot visible, then input mouse mode equals mouse mode visible, else input dot mouse mode equals mouse mode captured. Let's take a look. Okay, it starts up normally. I can move and look around, and then I tab and I can see the mouse. So yep, everything's working. Okay, so we can toggle our inventory interface view, but what we can't do is actually interact with it yet. And what we want to be able to do is we want to be able to click a slot, left click or right click it, and then get some visual feedback in the inventory interface. But in order to do that, we'll also need to know what inventory that it's coming from. And since we're not storing that anywhere, we'll have to send a signal from the slot to its corresponding inventory data, and then send a signal from there to the inventory interface. So let's set this signal up first. So I'm going to go to my slot scene here, go to the root node, signals, I'll go to GUI input, I'll connect that, and then I'm going to drop a hefty if statement in here. So let me copy this, and then I'll paste it right here. So we are going to check that it is a mouse button. We're going to check to make sure that it's either a left or a right click, and we're going to check to make sure that it is currently pressed. And we'll make a signal, I'll call it slot clicked, and we'll emit it here. And what we'll pass in as arguments for it is we'll pass in the child index, and we'll also pass in the button index of the event, so we know if it's a left or a right click. And let's make that signal appear quick. So signal slot clicked, and this will be index int and button int. Okay, so there's that signal, but where do we connect it? Well, we're going to connect it in the inventory script, and we'll connect it in populate item grid, but currently we're just passing in the slot datas, not the inventory data itself, and each slot is going to have to connect to the inventory data. So let's change up this argument here. So I'm going to copy this, then I'll paste it down here, and then I'll get rid of slot datas here, and then here I'll just type inventory data dot slot datas. And that's it. Everything works exactly the same. And now we can just wire this up so that we go slot.slotClicked.connect, and we'll connect it to inventory data, and we'll make a function in there called onSlotClicked. All right, so let's make that function now. And I'm going to go back to my slot script here, and I'll copy this signature, and let's go to inventory data. I'll just control-click inventory data here. So func, then I'll paste that signature, put onSlotClicked in front of it, void, and then for now, let's just say print inventory interact. And let's see what we got. Okay, so we've got that first signal wired up. Okay, we've got the first signal set up from slot to inventory data, and now we just need to set up one from inventory data to inventory interface to get that interactability going. So let's do that. So in inventory data here, I'll make a signal inventory interact, and I'll pass in these same parameters here. And then in the beginning, let's just say inventory data, because again, the interface doesn't have a reference to it, so we have to pass it in the signal. So then let's emit it here. So inventory interact, emit, and then we'll just say self, index, and button, and then Shift Alt O, I'll go to the inventory interface. And then here we'll say func on, and then let's go back and copy that signature. Then I'll just paste this all here. It'll return void, and let's hit enter here just so we've got more space, we can see everything. And then here, let's just print, I'll set formatted string here and just pass all these in so we can see. So inventory data, index, and button. And then to connect it here, I'll just copy the function name, and then I'll go inventory data dot inventory interact connect, paste that in, hit play, and then let's take a look. Yep, so we can see the different indexes and buttons are working, and it passes in that inventory data. So this is something we can work with. So the first order of business is making it so that we can grab a slot data so we can use it in the inventory interface. So we'll need a variable to store that slot data. So up here, I'll go var grabbed slot data. This will be of type slot data. And then let's start setting up some logic down here. So match grabbed slot data and button. And then if that matches null and mouse button left. So this is just saying if we currently have no slot data grabbed and we're left clicking on the slot, then run this. So we'll say grab slot data equals inventory data dot grab slot data. We'll pass in the index. And let's make this function here. So I'll copy this, and then I'll control click into inventory data. And so up here, func grab slot data, we'll pass in the index here, and this will return a slot data. So var slot data equals slot data's index. And then let's check to see if it's null. And if it's not null, we'll return it. Otherwise, we'll return and grab nothing. So if slot data, then return slot data, else return null. All right, and let's just make sure if that's working, print out here at the end of the function here, print grabbed slot data, and take a look. So if I'm clicking on something empty, it doesn't set anything, but if I click on something with an item in it, we can see we actually grab that data. So now let's set up a UI for that. In order to add a display for the grabbed slot data, I'm going to click inventory interface over here, Control-Shift-A, and add a slot scene. I'll call it grab slot. Then I'll click drag it over here, hold control as I drop it to get a reference to it. And let's make a function to update this display. So func update grabbed slot. This will just return void. And then we'll check if grabbed slot data, which means if we are currently grabbing something, then we'll say grabbed slot show. Let's reveal it, and then let's update the slot data. So grabbed slot.set slot data, and we'll pass in grabbed slot data. And if we don't have anything grabbed, then we will just hide it with grabbed slot.hide. Okay, so, and then instead of printing this off here, let's just call this function, and let's see what this looks like. So currently it starts off displayed, but you can see if we grab nothing, it hides. And then if I grab something, it displays. But we don't want this panel to show, and we don't want this to be at full opacity. So first, we're going to hide it by default. And then let's click, so for grab slot, go to visibility, self-modulate, I'll turn to 0 on the alpha just so that the panel doesn't display. And then for modulate, I'll just turn it halfway so that sprite isn't at full opacity. And then to make it so that it follows the mouse up here in the inventory interface script, I'll go func physics process, and I'll say if grab slot visible, then grab slot.global position equals get global mouse position. And we don't want it to be right under the mouse because then it'll display the tooltip. So I'll just say plus vector2 5 5. And now let's take a look. There we go. That's looking pretty good. So we can currently pick something up, but when we pick it up, we're not actually removing it from the inventory or updating the UI. So let's take care of that. So I'm going to go to the inventory data script. So Shift-Alt-O, search data, open inventory data.gd, and let's make a signal that we can emit whenever we update the inventory. So signal inventory updated, and then we'll pass in inventory data, just like that. And so here, when we're grabbing a slot data, let's say slot data's index is equal to null. So let's update the inventory so that this is now an empty slot. And then let's emit that signal with inventory updated emit, and we'll just pass self into there. And then we just have to connect this to the inventory script. So inventory.gd right there. And we'll connect it right here. So inventory data dot inventory updated dot connect, and we'll connect this to populate item grid, and populate item grid also takes in an inventory data, so this should work just fine. Let's take a look, and there we go, it's updating. So we're able to pick things up from this inventory, but we're not able to drop anything. So let's fix that next. So I'll go into the inventory interface script, and then right here in this match, I'm going to copy this and I'll paste it, and then let's change a couple things up. I'm going to change this null to an underscore, which this underscore is just a wildcard. So that means that this can be anything, right? So this will pick up null, but if it makes it past it, then if it's not null, meaning that we do have something in the grabbed slot data, then this works here. And we also want to make sure that it's a left click. And here we'll say grabbed slot data is equal to inventory data dot drop slot data. And because we're dropping it, we're going to have to pass in the grabbed slot data as well. And we'll also pass in that index. All right, so let's copy this and then make this function in inventory data. So I'll control click here into inventory data, and I'm actually going to copy this entire function, paste it here, change this to drop. Let's just make some changes. So again, we're going to have to pass in the grab slot data that is of type slot data. All right, and let's take these two lines and put them in front of this if statement. And so we're going to get the current slot data. We're going to set the slot data to the grabbed slot data. And then we'll emit the inventory updated signal. And then we will return the current slot data if there was something there. So we will effectively be swapping something if we're dropping into a slot that has an item data. Otherwise, we will return nothing. So let's see if this works. Okay, so I can pick up the apple and I could drop it, and I can swap with the book. But we can see that the quantity label is not updating properly, so let's just fix that quick. So Shift-Alt-O, go into the slot script, and then all we have to do is, in this if statement here, we'll just add else quantity label dot hide, and that should fix our problem. Yep, there we go. So I actually just realized that in the drop slot data function that we just made, if slot data is null, we're still returning null, so we can actually just rewrite this as return slot data, and it would work exactly the same. But if I go to my test inventory here, and I go to my Apple slot, I'll copy this and then paste it in the slot below, we'll see that we currently have a problem where these should be able to stack together, but they still just swap like normal. And that's because we don't have any merging code yet. So let's make it so that stackable items can merge together when possible. So I'll control click into the slot data script, and then let's make some functions here. So func can fully merge with other slot data of type slot data, and this will return a bool. And we'll check for a couple things here. So return item data is equal to other slot data dot item data. And let's check that it's stackable. So item data dot stackable. And then let's make sure that it doesn't go over the max stack size. So and quantity plus other slot data dot quantity is less than max stack size. So let's copy this signature. So if it can fully merge with it, let's make a function that merges them together. So fully merge with, and this will return void. And I'll just say quantity plus equal other slot data dot quantity. Okay, so let's go back to the inventory data function. And then these 3 lines at the bottom of the drop slot data, I'll just clear that out. So var return slot data. This will just initialize as null. So if slot data exists and slot data dot can fully merge with the grab slot data, then slot data fully merge with grab slot data. And if that's not the case, then we'll say slot datas at index will equal the grabbed slot data, and then we'll make the return slot data be equal to the current slot data. And then we will once again emit our inventory updated signal. And then we will just return that return slot data. And let's take a look. Okay, so yep, they merged just fine. And just to make sure that it doesn't merge if it's too high, let's go to one of these and set this to 90. And I can move everything like normal, and these swap because it would exceed the max stack size. So yep, everything's looking good. Okay, so now we want to add the case where if we're holding something and we right click, we're going to drop just a single of what we're currently holding. So I'll control click into the slot data script here, and then down here I'll make a function to create a single slot. So func create single slot data, no arguments, we'll return a slot data, and var new slot data equals duplicate. And then we'll say new slot data dot quantity is equal to 1, and then we're subtracting 1 from this slot data that we're currently referencing. So we'll say quantity minus equal 1, and then we'll return the new slot data. Okay, so I'll save that and then go to the inventory interface. I'm going to copy both of these in the match statement here. Copy that, paste it, and then I'm going to highlight left here, Control D to use multi-cursor to select the other one, backspace, and I'll type right there. So these are going to be our right-click cases. This one, where it's null, will actually be a case for using the item, but we're not going to do that for a while, and then this will be the single drop. So after here, I'll just put drop single slot data, and then let's make that function. I'll control click into drop slot data. Let's copy the first 2 lines, and then go down here, paste that, it'll be drop single slot data. And then here, let's see, if not slot data, then we'll say slot datas at index will equal to grab slot data dot create single slot data, and then we'll want to update the inventory. So inventory updated dot emit self, and then if grab slot data dot quantity is greater than 0, then we will just return the grab slot data, else there isn't anything there, so let's just return null. So let's take a look at this. And now we can pick it up and we can drop single slots, but they're not mergeable, which we want to address. So this can fully merge function is not going to work. I'm going to control click into it. Then I'll copy the entire thing, paste it here. This checks to see if you can fully merge with it, as in, the entire quantities of both can merge together, but we don't need that. We only need to check if it can add 1. So I'm going to remove this equal sign and then other slot data quantity. So it's just quantity is less than max stack size. And then I'll rename this to just can merge with. Okay, and then let's go back to the inventory data script. And so in drop single slot data here, I'll just add one more if statement. So elif slot data dot can merge with, this will be grabbed slot data, and then it'll be slot data dot fully merge with this grabbed slot data dot create single slot data. Okay, and then everything should work fine. So now they can merge and everything works like we expect it to. Let's add a chest that the player can use to store items in. So first I'm going to go to player script. We need a method for the player to interact with the environment. So I'll click camera 3D, Control A, add a raycast 3D. I'll call it interact ray. then I'll come over here, I'll set the target position of y to 0 and z to negative 2.5, and then I'll set the collision mask to 3 and uncheck 1, so 3 will be the interactable layer. Then I'll go to the player script, go up to the top, and drag an interact ray and hold control as I drop it so I can get a reference to it. Then I'll go to project settings, input map, I'll add a new action here, I'll call it interact, and then I will bind that to the E key. Then in unhandled input down here, I'll go if input.is action just pressed interact. Then I'll make a function called interact. I'll go to the bottom and make that here. So func interact, this will return void. And I'll just say if interact ray.is colliding. Then for now, I'll just say print interact with, and then I'll say interact ray.get collider. Okay, so now let's make a chest that we can interact with. So I'll click this plus button, other node, make a static body 3D, and I call it chest. And I'll go to the 3D view here, click the root node, Control A, add a mesh instance 3D, and I'll set that mesh property to a box mesh. I'll go to transform down here, set the position to 0.5, and then up here in this menu on top of the viewport, I'll create tri-mesh collision sibling. And then I'll go back into that mesh, make a new standard material 3D here, and go to albedo, and I'm just going to assign a bright green color to it. Okay, and I'll save this in create folder. I'll call a folder interactable, and I'll save that there. And actually one more thing, static body here, we want to set the collision layer 1 is good because we want the player to be able to stand on it, so that would be like our environment layer. And then I'll set the layer to 3 as well, and I'll just uncheck mask because we don't need that. But we need 3 so that we can interact with it. So anyway, I'll go back to the main scene, click on the root node, Control-Shift-A. I'm going to add a chest here, and I'll just Control drag it out a little bit, and let's try to interact with it. So I'll walk up, press E, and there we go. And the last thing that we want is probably a little crosshair that the player can use so that we can see where the center of the camera is. So I'll go back to the player scene, click the root node, Control A, I'll add a color rect, and then I'll click the color rect, go up here, click the center, and then I'm going to hold Alt and just drag one of these corners in so it's nice and small. And then I will also go to mouse here, filter, ignore, just so that this doesn't block our mouse input when our mouse is captured. Okay, and that will work. So if we're going to interact with an inventory in this chest, we're going to have to find a way to wire up that data to the inventory interface. So let's get started with that now. I'm going to go to my chest scene, I'll add a script to it, chest.gd. So let's add an inventory data here. So at export var inventory data of type inventory data. Let's make a signal so that we can open up the inventory interface when we interact with it. So signal toggle inventory, and then we'll pass an external inventory owner, and then we'll throw this signal when we interact with it. So let's make a function so that we can do that. So func player interact void, and then I'll say toggle inventory emit self. And then instead of passing in the data, we're going to pass in a reference to the node that owns the inventory data so that down the line we can connect and disconnect the data from the UI. You'll see what I mean later when we do all of that. But for the time being, let's just go to the main scene, main script here, ready function. So how are we going to wire this up? Well, what we're going to do is we're going to add the chest to a group. So I'll say for node in get tree.get nodes in group, and that group is going to be external inventory. And then here, I'll just copy this line here. And then I just have to change this to node. And then this toggle inventory interface, we're going to change this so that this accepts an external inventory owner. So external inventory owner, but currently when the player emits this, it doesn't pass in anything. So we'll just set this equal to null by default so that both work. And let's assign this group. So I'll copy this, I'll go to chest, root node, node, groups, paste that, and just add that to the group there. Then let's go back to main here. And let's say that if external inventory owner is passed in, then we'll say inventory interface dot set external inventory. And then we'll pass in that external inventory owner. And I'll copy this. And I'll go into the inventory interface and let's make this function. So func set external inventory void, and then let's just print that for now. And then we just have to make sure that the player is actually interacting with the chest to trigger this. So I'll go back to the player script, and then here I'll just change this to interactArray.getCollider.player interact. So this should print something here. What if I walk up and press E? There we go. Now that we've got access to the chest and the inventory interface, let's make it so that when the chest has an inventory data, we can actually see it in the UI. So first, I'll click the chest in the main scene, and I'll give it a new inventory data. Let's just give it a few slots here and a new slot data. Then I'll go to items. Let's give it a blue book in the first slot. Then I'm going to click player inventory here, Control D to duplicate it, and I'll call it external inventory. And I'm going to make the inventory interface visible here, and I'll drag it over here to the right, just so that the external inventory doesn't get in the way of the player inventory. So let's hide this by default, and then I'll hide the inventory interface again. Then I'll go into the inventory interface script. I'm going to go var, and I'll copy external inventory owner here. We're going to need a persistent reference to this so that eventually when we close the inventory, we'll be able to disconnect the signals that we are about to connect right now. But then this is the same name as this, and that kind of conflicts. So I'm going to put an underscore in front of the one here. Then let's write some code here. So external inventory owner is equal to underscore external inventory owner. And then let's get a reference to the inventory data with var inventory data is equal to external inventory owner dot inventory data. And then I'm going to copy these two lines from set player inventory data right here. And we don't want to set it to the player inventory. We want to set it to the external inventory. So I'll drag this in here, hold control as I drop it. Whoops, sorry about that. So let's try that again. Okay, external inventory. Then I'll paste that in so it sets the inventory data for the external inventory. And then we just want to external inventory dot show so we can see it. There we go. And I can even drop things just like that between the two inventories. Okay, so we can open the inventory, but if I leave and reopen my inventory, you can see that it's still there. So we need to set up the way to disconnect that data now. So I'll go into the inventory interface script. I'm going to copy the set external inventory function, paste it down here. We're going to kind of create the inverse of it here. So I'll call it clear external inventory, and we don't actually need to pass it an argument here because external inventory owner is persistent because we set it in set external inventory. So I will paste this down here and set it equal to null at the bottom. And we don't want to run any of this unless this is not null in the first place. So actually up here, I'll put if external inventory owner, and then I'll highlight all these lines and press tab to move that over. And then let's go through these. This is fine. Inventory data, we'll change this to disconnect, and then external inventory, we'll change this to clear inventory data. We'll make that function in a second. And then we'll change external inventory show to external inventory hides. Now let's make this clear inventory data function in the inventory script. So I'll go here, and then I'll copy the first two lines of set inventory data, and I'll paste that down here. Let's call it clear inventory data, and then we'll just change this to disconnect, and that'll work fine. And then all we have to do is go to the main script, and then at the bottom of toggle inventory interface, I'll put an else statement, and then I'll just say inventory interface dot clear external inventory. And this works for the most part, except, so you can see it clears there, but if I use E to interact with the chest again to toggle it, it actually causes an error there. And that's just because whenever we use E, it's running this path, but we only want it to run this path if the inventory interface is visible. So I'll just add that here. So and inventory interface dot visible. So let's take a look at that. And now if I'm using E, that's fine. And if we're away from the chest, it doesn't work. Okay, looking good. Next up, we want to make it so that we can pick up and drop items. So let's make a scene so that we can do that. I'll click plus, other node. I'll make the root node a rigid body 3D, and I'll call it pickup. Then I'll press Control A and add a sprite 3D, and we'll make the texture of that. We'll go into the item folder here and drag in the item atlas. I'll go to transform and make the sprite 3D scale equal to 2. And you can see it's kind of blurry. So if I go up to flags here and I change the texture filter to nearest, then that will make it a more clear pixelated image. Okay, and then I'll go back to the root node, Control A, add a collision shape 3D. Go to shape here, new sphere shape. I'll press R to go to scale mode, and then just click and drag in until it surrounds about that much. Then I'll go back to the root node again, and I'll add Control A, Area 3D. And I'm just going to duplicate this collision shape 3D with Control D, and then drag that into the Area 3D. The rigid body is going to be so that it doesn't fall through the environment, and then the Area 3D is going to be what monitors a collision with the player so that we can pick it up. So let's set the collision layers for that. So for the rigid body, I'll go to collision down here, and it doesn't have to sit in a layer, but we'll have the mask equal to 1 because that's the environment layer. Then I'll go to the Area 3D, and for collision, again, it doesn't have to be in a layer, but we're going to make the player layer 2, so we'll set the mask equal to 2. Okay, so then I'll save this. I'll save it in the item folder here. I'll create another folder in there called pickup, and let's save it right there. Okay, then I'll go to the main scene and Control-Shift-A, Q to go back to the normal gizmo there, and let's drag it up on top of the chest here. And before I forget, I'm going to go to the player scene, and I'll click the root node here, go to collision, and currently the player is on layer 1. Let's change that, so I'll remove the 1, and I'll set the player layer equal to 2. Okay, so let's hit play. Okay, so that collides as expected, but there's actually one problem here. So if I move it over here, what should happen is, yep, it'll fall like that. And if we don't want it to do that, I'm just going to go back here. I can click the root node, and then I can just click lock rotation, and then it should stay in place just like that. Okay, so let's set up the script for this pickup scene. So I'll click the root node, create a script, pickup.gd. This thing is going to store a slot data, so at export var slot data of type slot data. Now let's get a onReady reference to sprite3D. I'll control drop it right there. Then let's add the ready function. Let's be sure to set the texture of the sprite3D to the item data's texture. So sprite3d.texture is equal to slot data.item data.texture. And then I'll add a physics process function here, and I'll say sprite3d.rotate y equal to delta, just so that it rotates a little bit and has a little bit of life added to it. Then I'll go to Area 3D node body entered, and I'll connect that to pickup right here. And then I'll print body entered for now, just so that we know it's registering when the player enters it. So I'll go back to the main scene now. Click the pickup that we have added, and then let's make a new slot data, and I'll go to item, items, and I'll just drag a blue book in there just so we can test out that this is working. All right, so we can see the blue book, it's rotating, and it registers when the player enters. And it's a little compressed right now, so one way that we can fix that is I'm going to pick the transparent icons image right here, go to import, and I'm just going to change this to lossless, and then re-import it just like that. And you can see that it is a lot cleaner now. Let's make it so that we can actually pick up the item and put it in the player's inventory. So I'll erase this print line here, and this body references the player, so we can access the inventory data of the player, and then we'll make a function called pick up slot data, and then we'll pass in the slot data here. We're going to make this function return a Boolean, so if it's true, we'll say the pickup was successful, and if it's false, we'll say that it didn't succeed. So if this function returns true, we will just queue free on the pickup. So I'll copy this, Shift-Alt-O, and go into inventory data, go to the bottom here, and then I'll make that function, paste it there. We'll pass in slot data of type slot data, and we will return a bool. And so I'll just put return false down here. So if anything fails in here, then we'll just return false at the bottom, so we know that the pickup wasn't successful. And then we'll say for index in slot data's size, if slot data's index. So if this is null, so if not slot data's index, then we'll pick it up. So slot data's index is equal to the new slot data, and then we'll have to emit our updated inventory signal. So inventory updated emit self, and then we will return true because we have picked it up successfully. So let's try picking up this book. All right. And then I just want to illustrate too that if my inventory is full, I cannot successfully pick up the book. So in the main scene, I'm going to select the pickup, and I'm going to change this from a blue book to an apple. And let's just give it a quantity of 5. And currently in my inventory, I've got room for 5 apples in both of these slots, but if I pick it up, it's just going to take a new slot, and I'd like it so that, if possible, it would merge with one of these first. So let's fix that. So Shift-Alt-O, go back to that inventory data script and pick up slot data. I'm going to copy this loop and paste it here, and we're going to make it first search for that. If there's a mergeable slot, it will take that instead, and if there isn't, then we'll just take an empty slot. So here I'll change this to if slot data's index, and let's say slot data's index dot can fully merge with slot data. And if that's the case, then let's just copy this. I'll paste it here, and I'll remove can, so we'll just make that slot data fully merge with slot data and emit. So let's take one more peek. Okay, so 10, and there we go, now it's merging. Okay, next up we want to make it so that we can drop items, and the way that we're going to drop items is if we've got something grabbed and then we click not on an inventory slot, just out here in the open on the inventory interface, then we'll drop it. So let's set that up. I'll go back to the main scene here, click inventory interface, go to node up here, and I'll select this GUI input event signal, and I'll put it on the inventory interface itself, so I'll connect that. Then I'll go back up to the top of the inventory interface script, and we're going to make a signal because we need to instance the pickup in main, so we'll have to send a signal to main. So signal drop slot data of type slot data. Then come back down here. We're going to have to check for a couple things here. So if event is input event mouse button and event is pressed, and we want to make sure that we're actually holding something so we can drop it. So and grabbed slot data. Okay, and then we'll match the event button index, and we'll be looking for mouse button left. So let's emit that signal then. So drop slot data dot emit, and then we'll pass in grab slot data, and then for now we'll just also print drop data. And let's test this out. There we go, looks like it's registering. So now let's actually wire up this drop slot data signal so we actually drop something in main. So I'll click inventory interface here, go to node, double click that signal, and I'll set it up in main. And if we're going to create a pickup when we drop something, we'll need a reference to the pickup scene. So const pickup equals, and then let me grab that from the pickup folder here, and I'll control drop that file right there to preload it. And let's set some code up here. So var pickup equals pickup.instantiate. And then we'll set the slot data with pickup.slotData is equal to slot data. And for now, we'll just set the origin of this to just right above the world origin. So pickup.position is equal to vector3.up. We'll change that a bit later. And then add child pickup. So if I back away from the origin a little bit and I drop something, we can see that it drops, but there's still a few things to address here. Okay, so a couple small things to fix here. First, let's make it so that when we drop something, we update the grab slot display. So I'll go back to the inventory interface script, and I'll remove this print line, and then here I'll just say grab slot data is equal to null. And then at the bottom of this if statement, I will just put update grabbed slot. Okay, so this should work just fine. So now when I drop something, oh, I wasn't far enough away, but you can see it updates properly. And then let's go to the player script, and let's get the drop location to be in front of the player. So we'll make a function here that returns that location. So I'll say func get drop position, let's call it, and this will return a vector3. First, let's get the forward-facing direction using the camera. So that's going to be var direction equals negative camera dot global transform dot basis dot z. And I know that seems a little bit confusing, but again, all that that's returning is the forward direction of the camera, which is the negative z axis of it. You can kind of see that illustrated here. Anyway, back to the script. Then we will return the camera dot global position, and then we'll just add that direction to it. So let's go back to the main script then, and then here, instead of vector3.up, we'll say player.get drop position. And now, if I drop something, it drops immediately in front of the player. Next up, we want to make it so that if we're holding a stackable item and we right-click, we'll drop just a single of what we're dropping. So let's go back to the inventory interface, and at the bottom here, let's add another case to this match here. So let's do mouse button right, and then we'll say drop slot data dot emit grab slot data, but this time we'll say create single slot data, and then we'll just say if grab slot data dot quantity is less than 1, then we'll set grab slot data equal to null, and that should be all we need. So now I can still drop, pick up, right click and drop the book, but now I can also drop singles of the apple, and it works just fine. Okay, the last thing we want to take care of with dropping items is that currently if I'm holding something in the inventory interface and I close the inventory, then I open up again, you can see I'm still holding it. And what we want to actually do in that situation is we want to drop what's being held. So I'm going to click my inventory interface node here, go to node, and then I'll double click visibility changed here, and then I'll hook that up to the inventory interface. And then right here, I'll say if not visible and grabbed slot data. So this is saying if I'm closing the inventory and I'm holding something, then we can just duplicate some of this code here. Then I want to drop the slot data, and then I just have to update the grab slot display as well. So now if I open up the inventory and I close it while I'm holding onto something, you can see it drops right in front of me. Okay, it's time to start thinking about using our items. So for starters, I'm going to go to my item data script here, and I'm going to add a function. So func use, and this will take in a target argument. It'll return void, and then I'll just pass here. I'm not actually going to put anything in this function. This just exists because we're going to make child classes that inherit from item data, but no matter what the child class is, we'll at least be able to call a use function on it, even if it doesn't do anything. So now let's create a child class here. So I'll right click on the item folder, new script, and then I'll call it item data consumable, and then this will inherit from item data. All right, and then I'll create that, and then let's copy this use function, go over there to the consumable, paste this in, let's give it a class name item data consumable, and then let's make a item that can heal the player. So I'll say at export var heal value, and that'll be an int. And then we're not going to do anything in the use function now, but we will later. So I'll just say heal the player in a comment for now. But let's make one of these items. So in items here, right click new resource. This will be item data consumable, and I'll call it health potion. So I'll save that. Then let's open that up. I'll give the name health potion, description smells like strawberries. Let's say it's stackable. For texture, let's drag in the item atlas, and again, don't forget to make it unique. Then let's go in here, edit region. If you're reopening this after closing the editor, you might have to change the snap settings again. So let's set the step to 32 by 32 again. And then let's find a potion texture here. Let's use this one right here. Okay, I'll close that. And let's set the heal value to just 1. Okay, so now we have a consumable item, so let's figure out how to use it. Okay, so let's add that health potion to our inventory, and then let's start getting some feedback when we actually try to use an item. So I'm going to open up the test inventory here, and then I'll go to my items folder. Let's create a new slot data up top, give it a quantity of, let's say, 4. I'll drag in health potion there, so now we've got that in our player's inventory. And then I'm going to go into the inventory interface script, and this right here, null mouse button right, this is going to be the use case for right-clicking on an item to use it. So let's make a function in inventory data, and I'll call it use slot data, and we'll just pass in the index there. So let's copy this, and then I'll control click into inventory data, and I'll put this function above pick up slot data. So func, paste that. Index is an int, it's going to return void. Let's get the slot data here, so that'll equal slot data's at index. And then if that's null, let's return. So if not slot data, then return. And right here, let's just, for starters, print slot data dot item data dot name. So let's take a look. Open this up. Okay, so it's registering the use there. We want, because this health potion is a consumable, we want this to decrement as we use it. So let's set that up for consumables. So up here, I'll say if slot data dot item data is item data consumable, then I'll say slot data dot quantity minus equal 1. And then if there aren't any left, we're just going to want to set this to null. So if slot data dot quantity is less than 1, then we'll say slot data's at index will equal null. And then we want to update the inventory here. So inventory updated, emit at the bottom, and pass self in. And now, if I open up the inventory, these ones, because they're not consumables, do not get used, but as I use the health potion, it decrements. But it doesn't actually do anything yet. All right, so let's make that health potion actually heal the player. So first, I'm going to make a new folder in the root directory, and I'm going to call it player just to keep things more organized. And then I'm going to drop both of these into the player folder right here. Then I'll save, and then I'm going to reload the project because moving around scripts and scenes that are in use sometimes make you have to reload the editor. Okay, I just reloaded. Anyway, now I'm going to open up the player folder here and create a new script, and I'm going to call it player manager. I'll create that and open it up here. And then here we're going to make this be a singleton, and I'm going to get a reference to the player here, so var player. And then I'm also going to make a function here that's also called use slot data. We'll pass in a slot data, which is obviously of type slot data, and that will return void. And for now, let's just pass on that. I'm going to go to the player script, and we'll set this in the ready function. So well, first we have to set up the singleton actually. So I'll go to autoload here, and then I'll go to the player folder, player manager, add that. Okay, there we go. And now I can reference it by player manager.player equals self. So now if I shift alt O, go into the inventory data function here under this print statement right now, I'll go player manager.use slot data, and I'll pass in the slot data here. Okay, so now if I go to the use slot data function, I can say slot data.item data.use, and then I can pass in the player here as an argument. So I'm going to go back to the item data consumable script here, and then let's actually set up some code that can start healing the player. So if heal value is not equal to 0, then let's call a function on the player called heal, and then we'll pass in the heal value. So let me go back to the player script, and let's add a variable here that stores a health, so var health, and let's just make it equal to 5. And then at the bottom, I'll just add another function called heal that takes in a heal value, that's an int, return void, and I'll just say health plus equal heal value. So now I'm going to load this up, and I'm going to go to my remote branch so I can see the player here. So you can see the health right here is set to 5. If I go back, and if I use a potion, you could see the health actually increases. So this is just one way that you could theoretically use consumables in your game. All right, let's make a hotbar so that the player can use items without having to open up the inventory. So I'm going to make a new scene here. I'll make the root node a panel container, and I'll call it hotbar inventory. I'll give it a margin container, and then in there I'll give it an hbox container. And then just to see how this would lay out, let's Control-Shift-A, add a slot, and then Control-D, so we've got 6 of them in there. Then I'll go to margin container, theme overrides, just like the inventory, I'm going to put 8 in all of these, and then I'm going to save this in the inventory directory. Then I'm going to go back to the main scene over here, go to UI, Control-Shift-A, and then add in that hotbar inventory. And I'll go to layout, transform, and I'll put the position for X and Y at 10. And then let's just see that this lines up with the top of our inventory. And that is looking just about right. Okay, let's start updating the display of the hotbar programmatically. So I'll shift-click all these slots and delete them, and let's add a script to the hotbar inventory. And I'm going to go into my inventory script here and copy this populate item grid function, go back to the hotbar script, erase all this, and then paste it here. We're going to make this work for the hotbar inventory as well. We're just going to have to change a few things. First, I'm going to rename it to populate hotbar, and then we don't have an item grid here, but we do have an hbox container, so I'll control drop that here to get a reference to it. I'll copy it, and then whenever I see item grid, I'll just paste hbox container instead. And then we need a reference to our slot scene, so up here I'll go const slot equals, and then I'll drag in the slot scene here, hold control as I drop it to preload it. And we don't need to connect this slot clicked signal since we won't be clicking anything on the hotbar. And then lastly, this slot data is we only want to pass in the first 6 elements of it. So here I'll put dot slice 0, 6. And this should work well. Now we just need to set up the connection to the inventory data. So let's make a function for that. I'll just copy the signature of this, paste it here, and then let's rename this to set inventory data. Then right here, let's connect that inventory updated signal. So inventory data dot inventory updated dot connect populate hotbar. All right, and then let's just call populate hotbar that first time as well. So populate hotbar inventory data. So now we just need to call this in the main script. So I'll go back to the main script here, and then let's get a reference to the hotbar inventory. I'll control drop it here, and then here in the ready function, I'll say hotbar inventory dot set inventory data player.inventory data. And this will work just fine, except it's always visible. So let's make sure we toggle that. And I'll do that in the toggle inventory interface function here. So if inventory interface is visible, we want to hide it. So hotbar inventory dot hide. Otherwise, hotbar inventory dot show. And now everything should be working like we expect it to. All right, so let's make it so that we can actually use the items in our hotbar. So I'll make a signal up at the top of the hotbar script, hotbar use index of type int, and then up here I'll also make the function unhandled key input, and I'll say if not visible or not event.isPressed, then return. And then here I'll say if range key 1 key 7 has event.keycode, then we'll hotbar use emit, and we'll emit event.keycode minus key 1. And so what this means is that this second one is exclusive here. So if the key code that we emit is in the range of key 1 through key 6, then we're going to emit the index of it in terms of the inventory data, because this will just be the key code minus key 1, which actually just has an integer value of 49. It's just a really easy way of emitting 0 through 5. Okay, so now let's connect it, and we can connect it here at set inventory data. So we'll just say hotbar use.connect inventory data use slot data. And that should be all we need. So right here, yep, you can see I can use the potion right over there. What if I move it over to 6? Yep, still works. The last big thing that I want to do is I'm going to walk through a really simple situation of creating something like an equipment slot and then creating an equipment item that you could put in that slot. So first we're going to start by making a new item type. So I'll right click on the item directory, new script. I'll call it item data equip, and this will inherit from type item data. And let's create that, and then let's open that script up, give it class name item data equip, and then let's say export var, give it a variable of defense, and that'll just be of type integer. Okay, then let's right click on items, new resource, search for equip. Let's make one of these. I'll call it iron helm, and then let's open it up, and I'll give it a defense value of 1, name iron helm, description will protect your noggin, something like that. It's not going to be stackable texture. I'll drag in the item atlas, and don't forget to make it unique. Then I'll go to edit the region, and I'll have to redo the grid snap here since I closed the editor. 32, 32, and let's select this helmet right here. Okay, and then let's just put this in the player inventory. New slot data, I'll drag in iron helm, and let's make sure that it's there. Beautiful. So if we want to make an equipment slot that is an inventory that can only store certain types of item data, I think the fastest way to do that would be to create a new inventory data that can only store certain item data. So I'm going to go to my inventory directory, right click, new script. I'll call it inventory data equip, and this is going to inherit from inventory data. So I'll create that. Then I'll go into that. Let's give a class name. Copy this, paste that, inventory data equip. Then I'll go into the inventory data script. I'm going to copy the function signature for drop slot data, and then I'll paste it right here. And then down here I'll put return super.drop slot data grab slot data index. So currently this it acts exactly the same as a normal inventory data. It just calls the parent class, which is what super is referring to here. But we're just going to add a check here to make sure that we can only drop in equip type item data. So if not grab slot data.item data is item data equip, then we'll just return grab slot data. And we want to just copy this function, put it down here, and then just put single in here as well, so that it does the same exact thing for drop single slot data. Okay, now let's actually put this to use. Okay, and let's actually add that equipment slot now. So I'll go to the 2D view, I'll make the inventory interface visible, duplicate the player inventory, and let's call this equip inventory, and then I'll go to layout, transform, and I'll put the X position to, let's say 450. Okay, save that. I'll hide the inventory interface again. Then I'll go into the inventory interface script. I'll drag in the equip inventory, control drop it. Then let's duplicate set player inventory data. And then I'll call this one set equip inventory data. And then I'll change player inventory here to equip inventory. Then I'm going to go into the main script here, and we'll go, well, let's just duplicate this set player inventory data line here. So this will be set equip inventory data, and then here we'll call player.equip inventory data. So let's just add that to the player now. So if I go to the player script, at export var equip inventory data, this will be of type inventory data equip. So let's go to the player, new inventory data equip, and let's just give it an array size of 1, and we'll leave it empty for right now. So if I open it up, we can see it's there now. I cannot drop anything in there except for if it's of type item data equip. There we go. Okay, the very last thing I'm going to show is just fixing a little bug where if we go far away from the chest while it's opened, it stays open, and we want to force close. So first I'm going to press Shift-Alt-O, search for the player manager script, go into that, and then let's make a function here where we can get the global position of the player whenever we want. So func get global position, and this will return a vector 3, and let's just return player.global position. Okay, and then let's go into the inventory interface script, and in the physics process here, let's say if external inventory owner and external inventory owner dot global position dot distance to player manager, this is going to be a big line, get global position. And then we'll say if that is greater than, let's say 4, then let's emit a signal. We'll make the signal called force close. We'll emit that. Let's make that signal up top. So signal force close. And let's connect this up in main. So right here, we can just say inventory interface dot force close dot connect, and we can just connect it to toggle inventory interface, and this should solve our problems. So now if I've got it open and I go far away, yep, it closes right away. All right, perfect. If you got through all of this video, hats off to you. This is a lot of stuff. I honestly wish I could have done more, but it already was a huge project. So I hope you learned something, and if you enjoyed it, please feel free to subscribe and let me know with a comment. Thanks a bunch. Bye-bye.